Hi everyone, welcome to our lecture for today. Today we will cover objects and classes and object-oriented programming. And we are going to have a lab today at the end of the class on objects and classes, which will also be recorded. And we are going to talk about the practice exam, midterm exam. The midterm exam is scheduled on Thursday, June 14th at 12 p.m. in Frey Hall, room 104. It will be followed by an online lecture with on the rest of the material that we are not going to finish today from the object-oriented thinking, and the lab also that covers object-oriented thinking. So let's start with the lecture, and then we are going to take questions about the midterm exam. The midterm exam will cover the material that we covered up to today, so up to and including multidimensional arrays in Java. So there will be questions from the first chapter. We talked about introduction to computers, how computers store data in binary. We talked about number systems and how to translate from binary to decimal and then to hexadecimal and octal. Then we had a chapter on elementary programming, how to declare variables. Then on selections, how to write if statements and certain methods that are available from the mathematical libraries and string libraries in Java. We also covered loops and methods in Java. We learned how to write basically a method with a return type, visibility modifiers, formal parameters or arguments. Then we talked about arrays and multidimensional arrays, and now we know how to write simple algorithms with arrays. We basically know how to shift arrays, how to delete elements in arrays, how to insert elements in arrays, how to sort and search elements in arrays, and so on. So today we start a different kind of programming. Basically everything that we talked about up to now is called procedural programming. We have the main method, we execute that main method sequentially from top to bottom, and during execution we may call other methods and execute those methods in the same fashion. But we haven't yet talked about how to store data or how to actually have data that also has associated methods, like for instance any kind of data structure in Java or any other programming language like Java. So the topic of today's lecture are classes. In fact, classes in Java are not only the execution program, but also templates for creating objects, instances of those classes. And these objects may have multiple data fields, basically values that can be together considered to be the state of that object. So let's start the lecture for today. We will talk first about objects and classes. So up to now we learned that there are 8 primitive types in Java, and we learned that 4 of them are whole numbers, 2 of them are reals, 1 is Boolean, and 1 is for characters. But we didn't talk in detail about complex objects. Like for instance, I would like to store all the data relevant to a student. Like in a table, I would like to have the first name, last name, Stony Brook identification number, maybe the internet ID, and so on. Maybe grades for multiple labs, and so on. So for that, we really need to actually create objects, instances of classes. Classes that may actually contain multiple data fields, multiple components, parts of the whole object. But this entire idea of programming an object-oriented or basically complex objects in programming started really with graphical user interfaces. In graphical user interfaces, users would like to have a library of basically classes of objects or components that can be inserted in a graphical user interface. Like for instance, I would like to have a button template that will allow me to create 2 buttons. An input text field template that would allow me to have text fields for first name, last name, and for other values, address, and so on. I would like to have checkboxes, radio boxes, where basically each one of them comes with its own behavior, that when we select one option in a radio box or a toggle box, I would like all of the others to be invalidated, only one option to be available at any one time. Similarly, I would like to create lists and so on. So really the opening problem for object-oriented programming, this new style of programming that we are going to talk about today, was not really databases, but actually graphical user interfaces. So what exactly is an object? In the real world, an object is an entity that can be distinctly identified and has properties. Like if we take, for instance, a phone, it has a set of properties. What's the memory size? What's the speed of the CPU? What's the battery size? What type of inputs it has, outputs, and so on. So an object has a unique state and has a behavior. For instance, what's the age of the phone? How many years I had the phone? Each one of my phones, and so on. So the state of the object is given by a set of data fields or properties with their current value. Like for instance, if I build a graphical user interface like a paint application, I would have multiple circles. Each circle in this paint application has a different radius. So if I ask what is the area of any given circle, the area of that circle should be computed based on the state of that circle, based on the properties like the radius of each one of the circles. So every object really has two parts: the state, which is the set of all the data fields with their values, and the behavior. The behavior is defined by the set of methods which are linked directly to that object. So basically they use the values of these data fields to set the values of any one of the to return a value for that behavior, for that method. So here below we actually have such a template. It's the class circle. The class circle in some graphical application like a paint application, each circle must have a radius, and it also carries a method getArea, which is available only to objects of the type circle. So with the object we can ask for this object what is the area of this circle. Then we have three circle objects, object 1, 2, and 3, each one with a different radius. So let's say that in that graphical user interface I have a circle with radius 1, one with radius 25, one with radius 125. For each one of them I can call the method getArea, which will return the area of that specific circle. So for the first one it will return the area of a circle with a radius of 1. For the second one it will return an area of a circle with radius of 25. Now what you actually see here is a graphical notation for object-oriented programming. Later we'll see that this is called UML. It's a markup language for actually users of object-oriented programming to design their objects, their data fields, and some of these tools that allow us to draw the UML diagrams, class diagrams, also allow us to generate classes out of the UML directly. So what exactly are classes? Classes until now, when we define a class, like you define your class ISBN, is a program. But in addition to that, in Java, a class is also a template which you can use to define objects of the same type. So a class would use variables, or basically data fields, to identify the state of the current object, and methods to define the behavior of the current object, and those methods are linked directly to the object itself. So we can ask for circle 1, the area of that circle. A class also provides a special type of methods called constructors which are invoked to construct objects of that class. And in fact, we already saw a bunch of constructors when we create a scanner with a new scanner, and we give that the data field is actually, the argument is the system input stream. Or new string, when we create a string and to that string we pass either no parameters, in which case it creates an empty string, or we pass an array of characters and it creates a string, a sequence of those characters into a single string object. So the constructor has the same name with the class itself, and it creates objects of that specific class. So let's go directly into coding. So we have the class circle. The class circle has a double data field radius equal with 1.0 by default. We have two constructors, a constructor for circle that creates a circle with the default radius, and a constructor for circle that takes a new radius and assigns to the data field radius the value of this new radius formal parameter. Now we have a method getArea, which returns, you see it takes no parameters because it's not a static method. Now finally we have the methods that are non-static. These are methods that are linked only to objects. So when we will have an object of the type circle, that object has a radius, and we can compute the area of the current circle. So now this pattern, the pattern that we see here, this class is in fact a template to create objects of the type circle, which each object has a separate radius. Okay, so we can create circle 1 as a new circle, circle 2 as a new circle with radius 25, circle 3 as a new circle with radius 125, and since the radius could be public, we could actually see that radius in a separate program. In this case, the radius is actually private, so this program will not work directly as is defined. You actually have to change the modifier for the radius. Now, usually this is not done. Usually we actually do encapsulation. Encapsulation means that any data field should be private, and we should access the data fields only through the through accessors and mutators, special methods to access those data fields. But let's actually implement what we currently have up to now and see what's the behavior of this specific program. So as I said, you can create a new class. Let's call it circle. And the new class contains nothing at the beginning. Basically at this point we can create the data fields like double radius, by default takes the value 1. We can create constructors like public circle that takes no parameters and creates a default circle with the default area radius. We can create another constructor, public circle, which takes a double value, new radius, and assigns that to the radius data field. And then we can actually implement a public method getArea, which returns the area of the current circle. So it returns radius square multiplied with pi. And we are going to use the pi constant in the math class to do that. Now, we can have a main method in the same class, but because of the fact that this is a public class, we can actually define the main method in a different class. So let's create a new class. We are going to call it test circle. This method will contain a main method. This class will contain a main method. And here we are going to create multiple circles. Let's say that C1 is a new circle with the default radius. So we are using the default constructor to create a circle with the default radius. So for instance, if we print what is the radius of this circle, it will print 1. And if we print what is the area of this circle, it will print 3.14159 and so on. Is basically the value of pi, because this is a circle with radius of 1. So you see two things here, that we can actually access the data fields of the current circle by using the period notation. Is an infix operator that allows us for this given object to extract the radius. And second is that we can call the method getArea for the circle C1 with the same period operator, which basically connects the object on the left hand side with the associated method in the right hand side. But we can create as many circles as we want. We can actually create another circle C2, which is a new circle with radius of 25. Maybe create another circle C3 with radius of 125, and each of them has basically different radius and different area. So basically every time we call for any one of these circles, either getArea or radius, it gets the radius and the getArea for that specific circle. So in this case it prints first the area and the radius of circle 1, then 2, and finally 3. So let's run it. Okay, so you see basically exactly what we predicted it happened. So let's actually do a few more exercises. Let's assume that we want to store multiple data available for a person. So let's create a new class person, and the new class person has maybe multiple data fields. First name, last name, address, and we can have constructors for this class. So let's define the public constructor person, which takes the three data fields. Let's say first name, last name, and address. And each value is assigned to the data field. So first name is assigned first name, formal parameter. Last name, it's assigned ln, formal parameter, and address is assigned a, formal parameter. And let's assume that for a given object of the type person, we return all of its data in a single string. So we are going to implement a public method, toString, which returns a string representation of the person. So let's say that it returns the last name, last name, concatenated with a comma, followed by first name, concatenated with, let's say, another comma, and address. So now in a separate program, we can actually create a test person, and we can create multiple persons. So let's create person Paul is a new person with the name, first name Paul, last name Fodor, and address Stony Brook. And we can create a different person, Peter, and this also a person let's call it Peter Schmidt, and address California. And now if we print these different people, Paul and Peter, and we invoke for each one of them the toString method. By default it invokes that toString method even if we leave it empty. So basically this or adding the toString is exactly the same. Each one of the two objects basically carries its own information. So we basically invoke the method toString and we get the first name or the last name for each one of those objects separately. And similarly, let's get for each one of them the last name. Each one of them basically comes with its own last name. Okay? So let's continue. Now, earlier we said that there is a visual representation of classes in programming languages that support object-oriented programming, and that is called UML, Unified Modeling Language. It's a markup language that allows us to actually write these classes in a visual representation that can be read by customers, by non-programmers, and in fact it even helps us to develop our class hierarchy and actually develop our classes in a graphical representation, and then we can actually add these classes in a programming language like Java. Okay, so we have in these class diagrams in UML two types of diagrams, classes and objects. And here we have the class definition. The class definition always starts in a rectangle with the class name separated from the data fields. The data fields usually are private, and we will see that that can be symbolized with the sign minus in front of the data field, and then followed by the constructors and methods in a separate rectangle, which basically contains the constructors first and then other methods. Again, we will have plus for public and minus for private to symbolize the visibility of each one of the data fields and methods. Once we have class diagrams, we can create object instances of those classes, which will only list two parts, which is the object, like for instance circle 1, circle 2, circle 3 of the type circle, and separately the data fields with their value. So radius was a data field. For each one of the three objects it has a different value. So radius is 1.0, radius is 25, and radius is 125 for the last circle. And if you want to actually write such class diagrams, the best way to do it is with tools. So in the lecture notes there are about a few tools that are available. On Blackboard I posted the one that I'm personally using, is called Violet. Violet is a Java program that in fact can be used to create these class diagrams. So once you download it, if you start it, it will basically open this graphical user interface where you select class diagram. So for instance, for our class, the one that we just created for person, we can create a class diagram. So let's call it person, and it has the data fields, first name of the type string, last name of the type string, and address of the type string. And in the methods we only had two methods: the constructor for person, which takes three data fields of the type string, and address of the type string, and does not return anything. In fact, it creates an object of the current class, and we have the method toString, which returns a string representation of the object. So now we basically created the class diagram in Violet. You can use Violet 2. It's a very easy to use class diagram, and you can export it. You can save it, or you can export it to an image file, like for instance a JPEG file. You can put it anywhere you want. I usually save it on the desktop. Let's save it. This is the person UML. And as we can see, you can actually open it and see the diagram when you implement your class. Okay. So on Blackboard, please download Violet and start basically developing your classes. So let's talk about constructors, data fields, and other methods. So first of all, constructors. They must have the same name with the class itself. They do not have a return type, not even void, because what they do actually create an object of the class itself. The return type is understood to be a reference to this object. The constructors are invoked using the new operator. When an object is created, they initialize the object, and the reference, the pointer to that object, is now copied in the reference variable. So for instance, if we have a class with the name class name, we can create a new object of the type class name and assign the reference, the pointer to that new object to the variable O, the reference type variable O. And here we have an example. My circle is a circle object which is assigned the reference of a new circle of radius of 5.0, and we basically will create objects of that class. Even all the classes that you've wrote up to now, they had constructors, although you haven't used them. A class can be declared without constructors, and by default you will get a no argument default constructor with an empty body implicitly declared in that class. So what that means is that you can create in Java any class you want. Like for instance, I can create a new class, let's call it my class, which is completely empty, and you can create let's say test my class, which has a main method. And although we didn't have any method in the class my class, you have by default a constructor of my class. So I can create my class M, which is assigned a new my class. So the default constructor is actually added by default in the class, even if the class is empty. In fact, you can actually at this point use that object M. You can print it, for instance. And it will invoke the method toString of that class, which basically is inherited from the class object, and it tells us that from the package CSE114, my class is created at this address in memory. So basically it gives us the fact that there is actually an object created and that object is available, even if that object did not have an explicit constructor. The toString method does not need to be added because it's already inherited from its superclass. In fact, the classes in Java, they implement, even if we don't write it explicitly, they implement a superclass. They extend already a known superclass called object, which we'll talk about next class. Basically, the class object is the root of the entire hierarchy of inheritance in Java. You can actually extend a predefined, you'd extend another class, or you can extend the class object. So, constructors, a class may be declared without constructors, in which case an argument constructor will be added by default. However, if you declare a constructor, like for instance you declare the public constructor my class which takes, let's say, an integer n as a parameter and maybe doesn't do anything with it. At this point, we cannot actually invoke the empty constructor, because the empty constructor is invalidated the moment that we create any other constructor of the class. So if we want to have multiple constructors, like for instance a default constructor for my class and another constructor, then we have to explicitly define the default constructor. So the statement that we actually saw in the lecture notes is not 100% correct, basically, or it is correct, because if you declare a class without constructors, then a no argument default constructor will be added. But if you declare constructors, then you will not have the default constructor added by default. Now, how do we actually reference the object's data? We can use the period operator, which is basically, it separates. On the left hand side we have the object reference variable, and on the right hand side we have the data field of that specific object. Like for instance, myCircle.radius gives us access to that radius, either for writing a value in that radius. We can, for instance, assign to radius a different value like 12 or 15, or we can print that value, or we use it in an expression. We can also invoke methods with the same notation, the period notation. Like for instance, myCircle.getArea, it calls the method getArea of the object myCircle. It uses the radius of this specific myCircle. So let's actually see an example. We had a class circle defined earlier. We create a new variable myCircle of the type circle. We assign to it the reference to a new circle of radius of 5.0. We create a different circle, your circle, which is assigned a new circle object, and your circle.radius is assigned 100. So this will basically create a variable of the type myCircle. It creates the new circle of 5, creates an object in memory of the type circle of radius of 5, and then the reference value, the address of that specific circle, is written in the variable myCircle. And the same happens for the second circle, your circle. Initially it has a null reference, then it creates a circle of radius of 1 and assigns the address of that circle to the reference type variable your circle. And if we want to modify the radius of your circle, we can actually assign a different value to that radius. So let's actually do this example. We had the class circle earlier, which basically has the two constructors, a data field and the getArea method. And now we basically create a new circle, myCircle, which is a new circle of radius of 5. We create a different circle, let's call it your circle, to which we assign a new circle of default radius, and then your circle dot radius is assigned a different value like 100. So now if we print the radius of your circle, it will print the new value, and if we compute the area of your circle, we'll use this new radius as the value that is multiplied with the radius that is multiplied with Math.pow. And that is different than the value that would be printed if we will print the area of myCircle, because the area of myCircle is smaller. It will be an area of a circle with radius of 5. So this basically will print the area of a circle with radius of 100 is 31,415 period decimal point 926 and so on. and then the area of a circle with radius of 5, which is 78.53. Okay. Now, we talked about static methods up to today. And all the methods that you've wrote up to today and methods that you will write in the midterm are static methods. You will define select sort, that is a public static method. And you will define binary search, that is a public static method. So all of these basically are methods which take as parameters all the arguments they need to compute the return value. They are shared by all the instances of the class. They are not tied to any specific object. And if we invoke them, we can invoke them either directly with the name of that method from the same class, or we invoke them with the name of the class preceding the static method. So for instance, for the power method in the math class, we would use Math.pow of 3 and 2.5. It raises 3 to the power 2.5. Static constants are also variables, final variables shared by all the instances of the class. So for instance, if I want a value to be remembered for the entire class, for let's say the golden ratio for geometric objects, or the value of pi, or the value of e, and so on, I would actually define it as public, static, final, and the name of the variable, the name of the constant with its value. And can only be assigned once a value. You cannot change it afterwards. Now, if you don't put the keyword static in front of your method, then the method must be invoked for a specific object. Like for instance, myCircle.getArea or yourCircle.getArea. It will be invoked with instance variables and basic with real instances of objects, and it may contain also instance variables, data fields that belong to that specific instance. So the difference between the two types of methods, static, are that they take as parameters all the values they need, and they may be preceded by the name of the class because we want to import them from a specific class in the Java API or in another class defined by us. While non-static methods, they are invoked from an object. We basically have to specify the object and then the method that we invoke for that specific object. Now, we also said that local variables are not initialized by default. Java doesn't assign any default value to a local variable inside the method. So for instance, if we have the main method and we define integer x, if we want to use later integer x, like for instance for printing, we would have to assign it a value. X would not have a default value, and we will get a compilation error if the variables are not initialized before they are used in an expression or printed. Similarly for strings, we have to assign a default value before we can actually use it in an expression and so on. But it assigns default values to data fields. So for instance, if we define a class student and the student has a string name data field, an age, integer data field, an is science major boolean data field, and a gender character data field. If we create an object instance of that class, like for instance in a main method we create a new student object, we can actually invoke the data fields name, age, is science major, and gender. And they will have values. Reference type fields like strings will have the null reference. The age, since it's an integer, since it's a number, will have the value 0. The default value is 0. Boolean data fields have the default value false, and the character data fields have the default value of the Unicode, the character with Unicode 0, which is an invisible character. Now, the only thing that we haven't discussed up to now is, what about this null keyword? So null in Java is actually a keyword. It stands for a null reference, basically the reference with value 0. It does not have a reference to an object, and this is a reference type variable. Name is a string. Therefore, it will hold a special value, and that value is called null. It's basically the null reference is different than 0, is just basically a reference to an object that does not exist in Java yet. The same thing if we actually create an object of the type student, but we don't actually assign the reference of an object of the type student, we only create a variable. The variable itself will have the reference 0, null. Null is the reference that doesn't point anywhere. So what exactly is the difference between variables or primitive data types, like the 8 primitive data types that we talked about before, and objects in Java? And in fact, in any other kind of object-oriented language that follows the same principle of primitive types and object types. So the difference is the following, that if we assign a value to like an integer I equal with 1, I is actually an alias for a location in memory that contains that value 1. If we assign to a circle a reference to a new circle of radius of 1, the circle variable C is a reference or an address of where the actual object is actually stored in memory. So we actually create an object of the type circle with a radius of 1, and the variable C is the address of that object, the reference to that object. And the difference actually is in the fact that if we actually pass this object as a parameter to a method, or we assign this object to another reference type variable, the two references now are pointing to the same object in memory. The same thing that happened with arrays. Arrays will be shared, and now we have two references to the same array object. So let's actually see exactly what happens. So let's assume that we first do a test for primitive type variables. Like for instance, we defined two variables, I and j. I was assigned the value 1 and j was assigned the value 2. Then we assigned I is equal with j. After the assignment, I will have the value 2 and j will have the value 2. If we modify I again, let's make it 3. I will be the value 3 and j will be the value 2. So really what assignment means is that we copy the value from j and we copy it into I. So basically the two objects are not connected. Now we have two objects, two variables, two different memory addresses where we have 2 and 2 after the first assignment. Now what exactly happens if we have circle variables like C1 and C2? C1 being a circle of radius of 5 and C2 being a circle with radius of 9. If we assign C1 is equal with C2, now C1 and C2 are the addresses of the same object of the type circle. The other object that basically was the original C1 is not referenced by C1 anymore. C1 is now the address of the circle with radius of 9. So is no longer referenced by anyone in Java, and it will be basically considered garbage, which is automatically collected by the Java virtual machine through a process which is called garbage collection, which runs in parallel with the current program that we are running. But the result is really the fact that the two variables are now pointing to the same object in memory of the type circle. So if we modify, let's say, the radius to any one of the two objects, the other circle will see that change in the radius. So for this to understand better, let's actually do a couple of experiments. So first thing that I'm going to do, I'm going to create the two integer variables I and j. And I'm going to assign to I the value of j, and if we print the value of I, it will print, of course, 2. But now if we continue this process and we assign to I a different value, let's say 3, and we print out the value of j, it still prints 2 for j. Although if we would print, for instance, the value of I, after we did this assignment of I with 3, it will print that the variable I is now 3. So really, when we assign j to I, we assigned the value of j is copied into I. So I and j are completely disconnected. Although now they have the same value, if we assign to I a different value, that will not actually change the value of j. And similar thing happens for j. If we assign now 3 to j, I will be 2 and j will be 3. So I and j are completely separated. Okay, now let's do a separate experiment. Let's create 2 circles. Circle C1 is a new circle of radius of 5. Circle C2 is a new circle with a radius of 25. And now we are assigning to C1 the value of C2. And of course, if we are printing the radiuses of C1 and C2, it will be the same, it will be 25. But now let's actually modify that radius. So after we connect the C1 and C2 are references to the same object, we modify the radius of C1. Radius of C1 is equal with 10. The question is, C1 and C2 are now the same value, because in fact C1 and C2 are pointing to the same object in memory. So although we didn't change the value of C2.radius, it will also change because of the fact that C1 and C2 are pointing to the same object in memory. So really, when we are changing C1's dot radius to a different value, it changes the object, and C2 will see exactly the same thing. Okay? Any questions? I'm watching the chat in a separate window. There are no questions about the lecture today. We are going to do the midterm review in a few moments. So we are going to respond to questions about, let's say, number conversions or other topics. Okay, so let's take an example from Java. Java provides us with a lot of classes. One of the classes that may be most useful for us is called the Java util date class. It's a class that encapsulates the current date and time into a single object, and it stores for the current date and time the number of milliseconds elapsed since January 1st, 1970s GMT. That is called the Unix epoch time, kind of like the beginning of computer science. It's basically a number of milliseconds from that date and time in the GMT time zone until now. And you can basically get that Unix epoch time and print that either as a string, which actually will print for that specific date, for the date that we are creating, what is the date, month, day, year, and time. But you can also get that long value. You can get the elapsed time. Get time will return that long value, which is the number of milliseconds from the Unix epoch time. You can print it. You can use it in date comparisons. So you can basically create 2 date objects and see which one is before another date object. Subtract them to get a number of milliseconds. And using the number of milliseconds, you can get the number of seconds, days, hours, and so on, minutes. Another class, which is also from the same package, java.util, is the random class. So we learned about math.random that generates random values. There are many other implementations to generate these kind of pseudo-random numbers. Basically, we can give to these random numbers, yes, we can give to these random numbers a seed, which is a long value that can be used in a function to generate random values. We can create random objects. We can actually get every integer for that random object up to, let's say, 1,000. Now, before we continue with static variables, constants, and methods, let's actually see if there are any questions in the chat about the lecture for today. And then after the lectures for today, we will talk about the midterms. So any questions about the lecture for today? Okay. So in order to understand really the difference between static and non-static, we can actually see that in an example between static data fields, like for instance number of objects, and non-static data fields, like for instance radius. A non-static data field is a data field that is connected for every object, like for instance circle 1, circle 2 will have a different radius data field. A static data field is a data field which is shared between all the objects of the same type. So for instance, the number of objects that were created with the class is really a property of the class itself. So how can we do that? We can actually, every time we create an object of the type of that class, we increment this number of objects. We can access this number of objects either by using the object itself, like circle1.number of objects, or we can access it using the circle class. The same difference applies between non-static methods and static methods. Static methods return a property of the class, and non-static methods return a property of any individual objects. Finally, in the UML notation, we use plus for public methods and variables, and we use minus for private data fields. Those static data fields or static methods are underlined. Basically, the meaning for that is that they are static variables or methods. So let's actually see this in our class. So earlier today, we created a class person. Let's create now a different class. We are going to create a class circle. And the class circle contains a private data field for radius of the type double, and we can actually make it public, a public data field number of objects of the type integer. And since we can't underline in violet, we are going to put an annotation that moreover this is a static data field. Similarly, we are going to do it for methods. Let's actually have multiple constructors, the circle no argument constructor, another circle constructor that takes a double as a double data field, let's call it new radius. We can implement a public static method, get number of objects, which returns an integer value for the number of objects. We can also implement the non-static method get area, which returns the area of the current circle. And now let's implement this in Java. So earlier we implemented the class circle. In addition to that, we are going to add an integer number of objects, and every time we create a new circle, we can increment this number of objects. So we can basically implement with 1. And we can do the same from the method, the other constructor. And now we can implement that static method, get number of objects, which returns the static data field number of objects. So now in our test class, let's say that we create multiple circles and each one is created with one of the constructors, it doesn't matter which one. Let's say that this is circle 4. We can see how many objects were created. So for the class circle, we get the method get number of objects, which actually will print 4, that there were 4 objects created from the class circle. And this is a static method, and the same in the class circle we have the static method, the static data field number of objects. Let's see if there are any questions. Sunday at 11:59 p.m. Okay, great. So we learned object-oriented programming. So by default, the class or methods can be accessed by any class in any package. Public visibility modifier means that the class data or method is visible in any class in any package. Private means that the data or methods can be accessed only by the declaring class to protect the data, basically not let users to directly modify the data. And we will use get and set methods to read and modify private properties. So what exactly this means? Let's return back to our example of the circle class, and the data field radius, we will define it as private, which means that from a separate class, like for instance if we create a circle with let's say radius of 5, for that circle C1 we cannot get or we cannot assign the radius. Basically it will tell us that that data field is private. And really the reason that that is done is that we don't want to let, although the type of that data field could be double, we may have some restrictions. Like for instance, I don't want outside users to assign a negative radius, to a circle. So I would like to have a control over like who is accessing and how is accessing the radius data field. So if I implement my data field to be private, I would probably give access to that data field through a get radius method. So let's implement a public method that returns a double get radius that gives me a copy of the radius. Similarly, if I want to allow users to modify the value of the private data field radius, I will implement a method set radius that, given a radius like a double new radius, it will allow us to check if the new radius is greater than 0. We can assign that radius to the radius variable data field. So why is this useful for? Because I don't have access directly to the radius anymore. I can't assign, let's say, a negative value to the radius, like -2. This is not syntactically correct now because the radius data field is private. Now if I want to assign a new radius to the object, I can actually call the method set radius with the new value, let's say 3, and then if I want to get that value, like c1.getRadius will give me the value of that variable, so I can get the value 3. But if I want to assign it a negative value, an incorrect value, it will not assign it. It basically will ignore it, that you can't directly assign values to variables because those are private. That's what exactly private means. That private means that the data cannot be accessed directly, and in order to access it, I can implement get and set methods to read and modify the private properties. And my implementation of set method can actually filter out values that are incorrect. So only values that are correct will be actually assigned to the data fields. Moreover, in several cases, users choose not to implement a setRadius method. So in this case, because of the fact that my object is private, my data field radius is private, and I only have a get method for that object, for that data field, I don't have a set method, I actually do not have a way, I don't give a way to the user to modify the data fields. So my object is in this case immutable. Once I create it with a constructor, no one else can actually modify that object. So to return back to the visibility modifiers, if you don't use neither public nor private as data fields, then by default the data fields and class and method are accessed by any class in the same package, but not from other packages. So for instance, if I have 3 data fields, a public one, a default modified one, and a private one, I can access it selectively from different classes. So for instance, public means unrestricted access. I can access it from any class in any package. The default modified data fields can be accessed only from classes within the current package. So for instance, if I implement the package java.util, I can access the data fields that are default modified from java.util. The private modifier restricts within a single class. So that means that private data fields cannot be accessed by any other class or method but my current class. So let's see an example. Let's consider that we have the package P1, and within the package P1 I have a class C1, and within the class C1 I have 3 data fields: X, which is a public integer, Y, which is a default modified integer, and a private data field Z. Similarly, I have also methods, a public method, a default modified method, and a private method. From a class C2 in the same package P1, from a method, let's call it a method, if I create an object of the type C1, I can access the data field X because it's public, the data field Y because it's default modified and I'm in a class in the same package with the class C1, but I cannot access the private data field Z. Similarly, I can invoke the public method M1, the default modified method or package level method M2, but I cannot invoke the private method M3. From a different package, let's call it P2, from a class C3, if I create an object of the type C1, the class C1, in the package P1 with a new operator and a constructor for C1, I can access the public data field, but I cannot access the default modified data field because I'm in a different package, and I cannot access the private data field because that can only be accessed in the same class C1. Similarly, I can invoke the public method, but I cannot invoke the default modified and private methods. Same thing applies to classes. If I define in the same package a class C1 and also a class C2, the class C2 can access the class C1. But from a different package, the class C3 cannot access the default modified C1 because the class C1 is only available within the package P1. Now, when we write these data fields in the graphical user interface, like UML diagram, like Violet, we would use the symbol minus to identify private data fields, and I did that for the class circle, and plus for public data fields. Now, in this case, my diagram is a little bit different than the one in the lecture notes because the number of objects data field is private, and here I define it as public. But I can easily modify it to define it also as private, and the class actually remains exactly the same. Any questions? Let's see if there are any questions, and then we'll continue with object-oriented thinking. Basically, how to create arrays of objects, how to define classes for any kind of task that we may have. Like, for instance, we would like to define a class for any data field, like a stock market ticker, for computing the BMI, the body mass index, let's say for a gym, for customers of a gym, and so on. Now, if we create an object, let's see if there are questions. Yes. So the question that we have in the chat, can a static variable be accessed within different classes? The answer is yes. If our static variable is public, I can basically go to a different class. So my static variable is a public, number of objects is public. I can access it from a different class. Like, for instance, from the class test circle, I can print the number of objects. I can access it. In fact, I can also modify it. So it doesn't really depend on the static, non-static issue. It really depends on the public versus private issue. So I can actually delete the modifier or put a private modifier, and then in the different class I cannot modify or read its value because they are basically private. But in the class circle I can choose to have it public or even default modified. Does that respond to your question, Sudeep? Thank you. Okay, excellent. So let's basically return to arrays of objects. So what if I want to store not one circle but an array of circles? What actually we have? That array is actually an array of the objects of the type circle. The notation that we actually used last class for declaring arrays of integers or arrays of other objects applies also in this case. We actually define a new array of objects of the element type circle, and we can assign it an array of 10 references to circles. Basically, the array of objects is an array of references. Each of the references will actually be a reference to a different object of the type circle if we assign that circle to the new element. So it's like double referencing. From the circle array we get to a circle array, an array of references to circles. And let's actually do an example with this case. So instead of creating a single array, a single object of the type circle, I'm going to create an array of circles. Let's call it A. Is a new circle array of 2 circles, and for every one of those circles, let's say A of 0, we assign the reference of a new circle of radius of 1, and maybe A of 1 gets a new circle of radius of 2, and then we can iterate with a for loop for every circle C in the array A. We can print the area of that circle. which will print two areas, the area of the circle with radius of 1 and the area of the circle with radius of 2. The same thing can be done with a standard for loop, not with a for each loop. For every integer I, starting from 0 index, as long as I is less than the length of the circle of the array A, and the action after each iteration is increment I with 1, we print A of I dot get area, which prints the area of the circle A of I. So now it basically prints those. Okay, good. So let's go deeper in object-oriented programming. We will go into the next chapter, thinking in objects, and how to create objects for any kind of task that we may have. Like, for instance, we can create objects for stock market tickers, we can create objects for storing the data of people and so on, for a social network and so on. So let's record the current lecture and continue with the next lecture.